Well, how are you doing? This is going to be hopefully a short video. This is just another element of how the sextant absolutely destroys the globe Earth. I've talked about this a few times, but because of other arguments, this has been a little bit foreshadowed or overshadowed. Right, make it very simple. This is hypothetical, okay? Hypothetically, on a globe, this is the GP of the star, right? Because this is directly below the star, right here. And this is the observer over here. So without even dealing with the curvature issue, right, for the elevation angles, right, if we just look at the zeniths alone, so the zeniths meet here at the center, right, so this zenith, the observer zenith, meets here, the GP, right, of the star, the zenith of that meets here. They are called the nadir, I think, right. The zeniths are above and the nadir are below, okay. So this is the observer zenith, this is the GP and the zenith of the star, right? So here is your elevation angle, okay? So if we, this red arrow here, that's your elevation angle. So you couldn't take an angle any further than that. If you could take an angle at all from here, which you couldn't because you don't have a 90. But if hypothetically you could make a pretend 90, this would be the best angle you could get. Because after this, you're probably not going to be able to see the star because the curve of the globe will get in your way, right? Or curve in that situation will get in your way. So this is then, right? So then you need to get the zenith distance, right? So this looks like it's nearly basically 90. So like your zenith distance there is going to be thousands of miles right across there. But this is the problem. The problem is this. Because you have diverging zeniths, what's happening is this, is that your zenith distance, which will be between the observer zenith and the star, right? That's the zenith distance, right? Is always going to be way, way bigger in distance in this situation than the curve down here between the GP and the observer. So this distance here, right, will never match up here. Because even if I straighten this out, it would be longer if I straightened it out, this blue line. If I straighten that out, it's going to be longer than it is there because it's a curve. But it will never match up here. This up here will always be way longer than the curve here, right? I'll just leave this up here just to show. This here, right, is a complete match of down here, right? As you can see, they fit perfect. I'll bring it up here. Look how small it is. So the zenith distance is never going to match the surface of the Earth. Never. On a globe Earth. Even if you could get 290s, which you can't, but even if you could, hypothetically, it was never going to match it. It'll always be wrong. All your distances will always be wrong. You know, because the GP is always of the star is always going to be at a different angle to the observer. So those zeniths are not going to ever be parallel. They're always going to be divergent. Now, there's another factor here. The stars in the heliocentric model are at massive distances away. So each star then has to be viewed from its distance as far as its zenith. Like if you're talking about zenith distance, right? Even though the distance is only ever going to be in minutes of degree, the point is that the zenith distance is always going to be greater than the distance along the Earth between the observer and the GP. Now, all this won't happen because you don't have a 90-degree angle at either of these places, and you need it to be you need the two zeniths to be parallel for this to work in reality. But on a globe, obviously, this doesn't work, right? Because the distances are going to be all wrong. The actual zenith distance will be way greater than the surface distance, right, between the observer and the GP. So if I just get the, 1 second now, looking for the, where is the magnifier? Show magnifier, right. So here is the globe Earth, right? And here is the zenith up to this star. And here we have the zenith distance. And then we come back down to the globe Earth. So I'll try and make it bigger, right? See if I can make it bigger. Right, that's not really helping, right? So, hide magnifier. So the point is that if we bring this star out further, right, here we are on the small one. I can't really do what I wanted to do. So if we bring it out further, that brings out the zeniths further, right? Now, we only have a certain distance that we can use with the, because it's minutes of degree, right? But the point is that no matter what way you work it, the zenith distance is always going to be greater than the curved Earth distance because it's diverging zeniths. It can never work. I mean, because no matter what way you twist and turn it, this is the limit of your angle. Even if you could get a 90 on a curved surface, which you can't, this here would be the limit of your angle. You know, once that star moves anyway this way, your angle to it is going to be blocked here by the Earth curve that would be on a globe. So you can't, it just doesn't work. It'll never work. The distances will always be out. That is your distance on the surface. This is your zenith distance. It's never going to work. It's just crazy to ever even think that this could work on a globe. I don't know how people worked and used sextants and believed they were on a globe. I really don't know how they did that. But then again, pilots do it, don't they? So, you know, and surveyors. So, you know, people can believe anything, I suppose, regardless of what reality shows them. So this is basically it. This is the end of the video. I don't see any way out of this because your zeniths, right, the zenith of the star and the zenith of the GP are always going to meet, right, the nadirs of it are always going to meet at the center of a globe. That's where they always meet. So they're always going to diverge. So because they're diverging, the zenith distance is always going to be completely wrong in comparison to the surface distance. And as we all know, let's say this zenith distance was 4,500 miles, right? Or 4,500 minutes of degree, right? Then this distance here has to match that as 4,500 nautical miles. But if this is a straight line, 4,500 minutes of degree, then how can this line come down here and be 4,500 nautical miles in this small area? You know, it can't. You know, and you know it can't. It just doesn't work. It's not going to work. It's never going to work. I really don't know. I don't know what you're going to come up with for this. Right? You can't even get an angle off of your surface. That's why you have to use the center. You can't get an angle off the surface. So everything everything has to go to the center where there is an equatorial plane on the globe. So, like, it's like even if he did create two hypothetical 90s, for what reason I don't know, you could never make it work. It just wouldn't work. That's the end of that.